Lifesavers, originally known as Fruit Tingles, are a part of a long line of Australian confectionery. Back in 1930, it all began when with Fruit Tingles coming out under the brand of Allen's. However, later, when the company was bought by Nestle, they were rebranded to be called Lifesavers. The other reactant in this equation is Coca-Cola. The famous soft drink originated back in the 19th century by Mr. John Permington as a patented medicine until the soft drink took over the world.
When a lifesaver is dropped into a bottle of Coke, a fizzy fountain of Coke and carbon dioxide erupts out the top. This occurs through a chemical reaction called nucleation, which assists in the separation of solids, liquids and gases. In this case, the microscopic grooves on the outside of the lifesaver allows molecules of carbon dioxide or CO2 to separate from the liquid, building them up in one spot. If enough molecules from this creates a bubble, which leads to more bubbles until you can see the gas erupt out the top, along with the Coke.
This experiment is being conducted to determine if a chemical reaction can be changed through a variety of ways. However, throughout this experiment, it will be found if the rate of reaction can be changed by the difference in the surface area. 3 different types of surface area will be tested. Firstly, the control, where the lifesaver will stay non-tampered with. Secondly, the lifesaver will be chopped in half, and finally, it will be ground up using a mortar and pestle. All 3 will be dropped into the same kind of Coke and all at room temperature. Once it is dropped in, using the camera, it can be shown how high the Coke shot up. After this, the remaining Coke in the bottle will be measured to see how much is left over.
The aim of this experiment is to evaluate whether the surface area affects the size and rate of reaction in a chemical reaction.
It was hypothesized that the bottle with the crushed Fruit Tingles will erupt the fastest, the largest, and will have the least amount of Coke left in the bottle.
For this experiment, you will need a mortar and pestle, a ruler, a plastic bucket, a packet of Lifesavers, a measuring beaker, and 3 bottles of Coca-Cola Light.
Inside, it's all I don't
We split one of the Lifesavers in half. That's in half, like that.
making up our minds. But if you think that learn.
Okay, now that the experiment is done, it is important that we analyse our results and discuss why these results occurred. In this experiment, the largest eruption occurred in the Coke bottle with the crushed Fruit Tingle. This eruption reached 1.5 centimetres. The smallest eruption came from the Coke bottle with the full Fruit Tingle. The full Fruit Tingle erupted the slowest, with the reaction occurring 2 seconds after being placed into the bottle. The crushed Fruit Tingle erupted the fastest, with only 0.5 seconds before it erupted. When the leftover Coke was poured into a measuring cylinder, it was found that the crushed Fruit Tingle left the most Coke in the bottle with 510 mils, and the full Fruit Tingle left the least with 360 mils.
The crushed Fruit Tingle had the quickest eruption because it had a larger surface area than the full and half Fruit Tingles. This allows more particles to react with each other at the one time, speeding up the rate of reaction. The crushed fruit tingle also had the largest reaction because of the large amount of Coke reacting at the same time and the shape of the bottle. This caused the Coke to shoot out the top. As a result of the slower reactions in the halved and full fruit tingles, the Coke just oozed out of the top, not gaining any real height. This is because the Coke was not reacting fast enough with the fruit tingles. The full fruit tingle left the least amount of Coke in the bottle at the end of the reaction. This occurs because the surface area is smaller, meaning that the reaction lasted longer. Even though it was not reacting very quickly, Coke was erupting constantly for a longer time.
There were some errors in this experiment. For example, the ruler wasn't very accurate as it only showed in 0.5 centimeter intervals. To improve this, we would get a more accurate ruler that showed in 0.1 centimeter intervals. This would make the measurements way more accurate. Another example is the measuring cylinder wasn't very accurate because it showed in 50 mil intervals. So this again wasn't very accurate, so to improve this experiment we would get a more accurate measuring cylinder. Another example comes when the crushed fruit tingle sat on the top and didn't react. We had to shake it, which could have changed the results. An electromagnetic stirrer could be used for all of them to ensure that the fruit tingles were dissolved into the Coke in all three cases. The last example is on our halved fruit tingle. Not all the halves went in at the same time because of human error. One was spilled. So to improve this, we would need a system where all the fruit tingles would have been put in at the same time. For example, there could be a piece of paper between the bottle and the container full of fruit tingles, and we could pull out the piece of paper when needed to.
This experiment complies with previous experiments on the rate of reaction in chemical reactions. Previous research and experiments on this topic have shown that the larger the surface area, the faster the rate of reaction, which was no different in this experiment. Although the rate of reaction supports previous theories, the size of reaction was different. As the same amount of fruit tingles was placed into the same type and size of Coke, this reaction should have been the same size for all three bottles. The shape of the bottle and the pressure created by the faster reaction meant that this wasn't the case in this experiment.
With our knowledge of this reaction, you could test this reaction with a different amount of Coke, or different amounts of Coke, different shaped bottles, different reactants, and different amounts of fruit tingles placed in the bottle. This could support or help to make this information from this experiment more accurate.
Science isn't meant for you.
In conclusion, this experiment was a success, with it being concluded that the larger the surface area, the faster and larger the rate of reaction. The hypothesis was partly correct, because the bottle with the crushed fruit tingles gave the fastest and largest reaction. However, the full fruit tingle had the least amount of Coke left over in the bottle. This experiment was very enjoyable and a real lifesaver.
Oh, science ain't out of style. Science never goes out of style. You love those iPhone apps.